Welcome to Homework Lib.
Hi, so in this case, what we're going to do is explain the concept of percent of abundance of an isotope. So first of all, for any element, we're going to have different isotopes. And each of them are going to have a certain percent of abundance. Let's say we're going to call it PIs as percent of abundance. So one easy example that we could treat is the case of bromine. Bromine has two different isotopes. We have bromine 79 and bromine 81. So for bromine 79, each of these isotopes is going to have a specific atomic mass. In the case of bromine 79, the atomic mass is 78.918 atomic mass units. In the case of bromine 81, the mass corresponds to 80.916 atomic mass units. So most of the problems that are related to the percent of abundance require you to calculate what is the percent using the atomic mass that you find in the periodic table. So now, how can we find the atomic mass that we find in periodic tables? Well, that mass is a ponderated average of the masses of the isotopes that we have present. So for example, in the case of bromine, if we look at the periodic table, we will find a mass of 79.9. And this is going to be equal to the mass of the first isotope. Let's say that this one, bromine 79, is going to be isotope 1, and bromine 81 is going to be isotope 2. We are going to multiply it by its percent of abundance, and then we're going to add it up with the mass of the second one multiplied by its percent of abundance. So, one thing that you need to always remember is that the sum of the percent of abundances, P1 plus P2, needs to be always equal to 1. So one nice thing that we can do is, for example, we can know that P2 it is going to be equal to 1 minus P1. So in most of the problems that you're going to find relating the percent of abundances, what you're going to need to do is, if you're given two different isotopes, you're going to need to find what are the values for P1 and P2. In order to do it, we're going to replace this quantity over here on P2, transforming my equation into M1P1 plus M2 times 1 minus P1. We can expand this, M1P1 plus M2 minus M2P1. We can factorize M1P1, no, M2P1, M2. We can factorize P1 and get M1 minus M2 times P1 plus M2. And this is going to be equal to my atomic mass that I find in the periodic table. So we can solve for P1. Solving for P1, we're going to get the value for A minus the mass of the second isotope divided by M1 minus M2. In this case, we can simply substitute the values. The value for A is 79.9, as I said here. That's the value that you find in the periodic table. The mass of the second isotope is 80.916. The mass of the first isotope, we said that it was 78.918. And the mass of the second one, again, 80.916. So with this, we're going to find that P1 is going to be equal to 0.509, which corresponds to a 50.9% of abundance of bromine 79. Next up, what we can do is go ahead and remember that P2 is 1 minus P1. So this would be a 49.1%, so 0.481, which corresponds to a 49.1% of bromine 81. So that is mainly the type of problems that you're going to find in this type of scenarios. The other possibility is that they are going to give you the percent of abundances and you will need to find the value for A. And in order to do it, you simply apply this equation. And depending on the number of isotopes, of course, here you could have more, let's say M3P3 plus the sum of all of the possible isotopes that we have of that element. And that would be all. Thank you.